Hello, today we're going to look at ratios and proportions. Ratio is an expression that compares two quantities by division. So we can have, oh, here we go. We can have 3 dogs in 6 kennels. We could have 2 candies per 1 trick-or-treater. So maybe reduce that to kid. Um, so we're comparing two quantities, and division is the thing that we're comparing it by. Sometimes ratios are written 3 dogs, and then they use a colon to 6 kennels. I really don't care which way you write your ratio. So if I want to find the ratios of up arrows to stars, I look and I have 4 up arrows. And it looks like I have 5 stars, so I have 5 stars. That's a terrible star, but hopefully you can deal with it. Now, a proportion is a statement of equality between two ratios. So like 2 kids or 2 candies per 1 kid is going to be this equal to 6 candies per 3 kids. So it's a statement of equality. There's an equal sign. And this ratio is equal to that ratio. Now, when we're solving proportions, lots of teachers teach different methods. Some cross multiply and divide. What I like to do is teach to cross multiply first. So we have 66x equals whatever 22 times 160. That answers 3,520. And now the last step is to divide. Now some kids learn cross multiply divide in one step, and that's fine when it's an easy problem like this, but when it's not, they get confused. So let's skip to number 3. And so now if I want to find the value of a, first we cross multiply. 18 times a is 18a. Now one trick here is that 12 is multiplied by this whole quantity. So you can multiply it to each term. So that's 12 times a plus 12 times 10, which is 120. So now, once we have that, now we solve for a. Notice that we don't just divide right away. A lot of people who are used to cross multiply and divide just want to divide right away, and they're not ready for it. So now a is equal to 20. All right. Now let's do 6. I'm kind of jumping around a little bit, but I think you could fill in the ones in between. F times F is F squared. 1 times 25 is 25. Now, the quick answer people say is 5, but there's actually 2 answers that fit in here because negative times negative 5 is also 25. So F has 2 answers, negative 5 and positive 5. All right, now there's something called similar polygons. Similar polygons are uh, are shapes that have the same shape, but not necessarily the same size. They're like the dilations that we were dealing with. So if you look at these have the same shape, they're just different sizes. So similar polygons, the corresponding angles are going to be congruent, but the corresponding sides are proportional. So BC isn't the same as FG, but C and G are going to be equal. Now, if two polygons are similar, we write ABCD is similar to EFGH. So it's kind of like the congruent sign without the equals because they're not, equivalent, but that sign means that they're similar to one another. So here's some quadrilaterals. Write a similarity statement and then solve for the missing values. So here we're on number 9. So if I go A, B, C, D, A, B, C, D, that's going to be equivalent to, now A has to match up with E, so E, F, G, H. And now if I want to solve for x, we can set up a ratio. 5 matches up with 5, or 12 matches up with 5, 15 matches up with y, 9 matches up with z, and x matches up with 3. So we look for the things that match up where both of them are numbers. Here we have 12 and 5. And now we set up a proportion. 12 over 5 is going to equal to x over 3. Then we cross multiply and divide. We have 5x is equal to 36, and divide it out, and what's that, 7.2? Now I'm going to switch to another color. So now that we have x equals 7.2, let's find y. We can still use the same ratio. 12 over 5 is equal to 15 over y. Cross multiply, 5 times 15, that's 75. 75 equals 12y. And now if I divide 75 by 12, that's what, 6 1/4. That's my y. So that's this value right there. Now I'm going to let you figure out z as we continue to the next. Oh, I guess we're done. All right, hopefully you can finish the assignment.